Okay. So the domain of a function is a set of all possible inputs for the function. So basically, these are the x values that are being used in order to evaluate a function. Or you can think of it as the values of x that are being used to graph the function. So we have this graph here. The only thing you want to focus on is the x values. So here, for example, if I draw from this x up or down, it does not touch the graph. So the only part where it begins to touch the graph starts at this point. So at this point, if I go up, I touch the graph. If I pick this point, I'm going to touch the graph. So all these in green are part of the domain because it's landing on the graph. Okay. So if I keep going here, this is actually going to go on to infinity. So if I keep drawing this pick an x here, if I come down, I don't touch the graph, but since it has the arrow, eventually it's going to hit it. So I'm going to be using all these x values. So we say that the domain starts at, I use a bracket since I have a closed dot, and it starts at, what is this here? -1 to infinity. Okay, so you're always looking at these x values here. When you don't have a graph, for example here, let me make this smaller. So first we want to evaluate the function. I'm going to look for the domain of f divided by g. Okay, so first we need to figure out what that is. So let's go ahead and, so f composed of g is equal to f of x divided by g of x. So f of x here is 5x minus 9 divided by g of x, which is 2 minus x. You want to simplify. In this case, I cannot simplify this any further. So to find the domain, you want to look at your answer here, and you want to ask yourself, since I have a fraction, there are some numbers that cannot be included in the domain. To find those numbers, we're going to take the denominator, 2 minus x, and set it equal to 0. So we subtract minus 2. So we get negative x equals -2 divided by -1. So x will be positive 2. So what this means is that this x equals 2 cannot be in the domain. And the reason is if you plug in 2 here, we would have 2 minus 2 is 0, and we cannot divide by 0. So we have to exclude that domain. So our domain is going to go from negative infinity to positive 2, union from 2 to infinity. So you have all the x values. So you can use all of these x values except for 2. So here's negative infinity, all of these numbers. You get to 2, we don't include it, so we use a parentheses. And then we start again from 2 to infinity. Okay. If you have a composition, like we do here, let me go ahead and move this picture down. When we want to do the composition, I'm going to do the domain. So find the domain of each function. So the domain of f, make this smaller. So let's do the composition. So here we have, let me get this marker. So here we have f composed of g of x. So g of x is x squared. And then I would plug in x squared in for my function f. So I'm going to have square root of x squared plus 4. And then the composition for g of f of x will be g of f of x, which is the square root of x plus 4. And then we plug this in for the function g. So we get square root of x plus 4 squared, which comes out to x plus 4. So now the domain of f, so if you notice here we have a square root. So when you have a square root, you want to set the radicand, which is the stuff inside, greater than or equal to 0. So here I get -4. So this is where the domain starts for radicals. So your domain here is going to go from -4 to infinity. The domain of g, notice it doesn't have a fraction, it doesn't have a square root. So automatically the domain would be from -infinity to +infinity. You only want to worry of finding these exclusions if you have a fraction or a square root. The domain of the composition, you want to look at the actual composition, but you also have to first look at the second function, in this case g. So for g, my domain is everything, -infinity to +infinity. So now for the answer, f composed of g, we get the square root. So f composed of g of x, the answer was square root of x squared plus 4. Since we have a radical, we want to set the denominator, the radicand, greater than or equal to 0. So we get x squared is greater than or equal to -4, the square root. X is greater than or equal to, this is going to be no real solution. And what happens here is, notice here, no matter what you put for x, a negative number will become positive, giving you this to be positive. If you put 0, you'll still get a positive number. So the domain for this is also all of these numbers. So the domain is going to be whatever they have in common, which is -infinity to +infinity. So the last one here, g composed of f. The answer that we got was x plus 4. Okay. So first, you want to look at the domain of the second function, in this case f. So the domain of f was -4 to infinity. Okay. And then number 2, you want to look at the domain of your answer, g composed of f of x. And that domain is -infinity to +infinity, since it's a line. So now if we draw a number line, it's going to be whatever they have in common. So this is 0 here. So I'm going to make this in red for the function f. So here's -4. So the domain for f is going to be all this in red. And the domain for the actual composition is going to be everything that is in green. So if you notice here, what they have in common is actually from here to here. So the domain for this composition is going to go from -4 to infinity.